In this video tutorial, we will look at exponential growth and specific writing and evaluating that growth model. So you can model growth by a constant percent increase with the following function. So we have a of t equals a times 1 plus r to the t. I'm going to cross off a sub 0. So a is our initial amount. R is our rate of increase. And that is a decimal. Oops, decimal. T is the number of time periods. So whether that be years, days, whatever we're measuring in. 1 plus r is called the growth factor because we're adding to it. It's growth, and it's a factor because we're multiplying. And then a of t is our final amount. Now, if we have interest that is a yearly rate and it's compounded over a specific interval during that year, we have a special name for that. That's compounded interest. And it is calculated using the formula A equals P times 1 plus R over N to the NT, where A is that final amount, P is the principal, which is the initial amount, R is the annual interest, N is the number of times the interest is compounded per year. So how many times per year? If it's monthly, it's 12 times. If it's quarterly, it does it 4 times a year. And T is the time in years. Let's look at our first example. So in 1976, the California seal population was 126 and increased by 11% a year since then. Write a function to model the population growth. Use a graph to predict when the population will be over 700. So we need to start off with a model. And in this case, it doesn't say compounded, so we just start off with our regular formula. So we have A of t equals our initial amount, which was 126. And then we have 1 plus the rate of increase, which is 0.11 in decimal per year, and that's raised to the t. Okay, so this is our model. And then if we put our model into the calculator and use x as our t, then we can go into second graph to look at the table. And if we scroll down, we notice that at the 16th year, it would be 669, and the 17th year would be 742. So it doesn't actually cross over until the 17th year. So we have 17th year. So 1976 plus 17. 1993 is when the population will be over 700. Let's look at our second example. We have Chester invests $2,500 in an account that pays 6.75% interest per year. After how many years will he have $4,000? So let's start off with A of t equals our initial amount, which is 2,500, times 1 plus our decimal of our percent, which is 0.0675, raised to the t. And then in order to find out when we will have $4,000, we can go ahead and put that into the calculator. Putting the equation into y equals, and then looking at second graph to see the table, we notice that at 6 years we have, or at 7 years we have 3,900, and at 8 years we have 4,200. So that would be the 8th year we'll have $4,000. And then how much will we have after 20 years? So if I go ahead and scroll down to 20 years, we will have $9,000 $232. And then what if Chester's investment was compounded monthly? So we need to rewrite our function. So we have A equals our principal, which was 2,500, times 1 plus the rate, which is 0.0675. And then we divide that by how many times a year? In this case, it's 12. And raise that to the NT, which is N is 12 times the year. So we go ahead and put that in the calculator. Once we enter the function into y equals, and then we go to the table and we look at the 12th year, we notice that we have $9,607.15. So a little bit more if we compound it monthly. And then let's try it if we compound it weekly. We have 2,500 times 1 plus 0.0675. And then weekly, there's 52 weeks in a year. So that would be 52t. And then we go ahead and put that in the calculator and check it out. And in that case, we have $9,635.13. So every time we compound it, the more times we can compound it, the more money we get. So you notice in an interest situation, that's good. If we were paying off a debt, that would be bad. So go ahead and try number 3. Pause the video right now, try number 3, and then come back and check your answer. Okay, go ahead and check your answers. See if you got them right, and if not, see what you did differently. And then go ahead for tomorrow and do number 4 and bring that in with you to class.